This video is on the objective calculate a margin of error given a confidence interval. And this is the first video for which I'm going over a question related to that objective in your Newton Alta homework. So again, if you're unfamiliar with the objective, what it's talking about, click on More Instruction, read the material there, watch the videos, take notes, see what you can learn from that. And again, I'm hoping that you've also been reading, your Chapter 8 Introduction in your OpenStax statistics book. All right. So this is another pretty simple objective, I feel. It's very similar to there was one objective titled, calculate a point estimate given a confidence interval. So here, suppose we know that a confidence interval for a population proportion is given by this interval here, right? The lower bound is 0.105, the upper bound is 0.355. So remember, this interval stuff is just a guess as to what the population proportion is, right? You say I'm reasonably confident with whatever percentage confidence. Like there should be a confidence level associated with a confidence interval. So like I'm 90% confident that, I'm 95% confident that, etc. So like what they're saying here is that, oh, we're reasonably confident that the true, the population proportion P is somewhere between 0.105 and 0.355. Now, a sample is taken, right? And they said with a sample proportion of P equals 0.23. Now remember this, the way a confidence interval is formed, the sample proportion or the sample mean, right, if it were x bar, is the value exactly in the middle. Right, that's called our point estimate. Now what they're asking for is the margin of error. Right, so again, I'm going to refresh your memory as to how a confidence interval is formed, and then we find we'll find our point estimate. Well, we're actually given our point estimate, right, the p hat, the sample proportion 0.23, and then finding the margin of error, right, that give or take in our guess. So again, here is how a confidence interval is formed. Remember, this one's about proportions, right? So they're saying that we're reasonably confident that the population proportion P, or it could be about a mean, mu, is between these two values. You have some lower bound and some upper bound. Now the lower bound is our point estimate. Right? The point estimate is a single value taken from our sample. So in this case, that would be our p hat. Right? In other cases, when they're talking about the population mean, when you're trying to guess the population mean with some confidence interval, it would be the sample mean, x bar. And then minus some margin of error, right? ME, margin of error. And the upper bound of our confidence interval is the point estimate. Again, in this case, for this particular problem, this particular question, that's p hat, our sample proportion, and then plus this margin of error. All right, so we're given here our lower bound, 0.105. The upper bound for our confidence interval in this question was 0.355. All right, and then again, the point estimate, the p hat, the sample proportion of 0.23 should be exactly in the middle. Exactly in the middle. All right, so that means that this value here is 0.23 plus whatever the margin of error is. And this value here, the lower bound, 0.105, this is 0.23 minus whatever the margin of error is. And then we could use that fact to figure out the margin of error, right? So How about I just use the upper bound? You could use the upper bound, you could use the lower bound. I'll use the upper bound. We know that 0.355 has to be equal to the middle, right, 0.23, the point estimate, plus the margin of error. And then I just simply solve for the margin of error. I subtract 0.23 here. So the margin of error is going to be 0.355 minus 0.23. Right. Now I'll make that 0.230. Now if I subtract these, that's 5 and 2 and 1, 0.125. Right, so the margin of error here is 0.125. This is the distance between the middle and the upper bound and the middle and the lower bound. And let's make sure that works. If I take 0.23 and subtract 0.125, yeah, that would be 0.105. So it does work. So again, another way to interpret this confidence interval is by saying that we're reasonably confident that the population proportion, P, is 23%, give or take 12.5%. And this margin of error is like a give or take in our guess as to what the population proportion or the population mean, mu, is. Now, you could have also done this. Right. You could have also done this. If you know the upper bound and lower bound, the margin of error is just half the length of the interval. Right? Because if you go from the lower bound to the upper bound, that'd be adding the margin of error to get to the middle, and then adding the margin of error again to get to the top. So to get from the lower bound to the upper bound, you're adding 2 margins of error. So if you take the upper bound and subtract the lower bound, right? Take the distance between the upper bound and the lower bound and then cut that in half. So let's try that out here. What's 0.355 minus 0.105 cut in half? Well, 0.355 minus 0.105 would be 0.250, or just 0.25, and then cut in half would be 0.125. Exactly what I found earlier by taking the middle, right, the p hat, and seeing how far that was from the top or the bottom. Well, again, you can find the margin of error this alternate way by taking the distance between the upper bound and lower bound and then cutting it in half. Right? The distance between the upper bound and lower bound should be 2 margins of error. All right, so after all that, we've discovered the margin of error was 0.125, and that's what I enter in my my spot there. Submit. Hooray, it is correct. Right? And again, read the answer explanations. Right? Even if you're right, but especially if you're wrong, right? Read the answer explanations. See maybe where maybe you can figure out where you went wrong, and continue on. All right. So that's first question on this objective, and they're all pretty similar. So I'll probably just do one more of these, one more video on these, and thank you very much for watching.